Okay, in this video we're going to be looking at pointers. Now pointers are unfortunately one of the things that most students find difficult. I myself found it very difficult when I first learned about them, so hopefully this video will help demystify them for you and allow them to use them within your own program. So let's start with a few definitions. Alright, so a pointer is basically a type of variable, and it's a special type of variable that contains the memory address of a value in memory. Alright, so you have an integer or a char, alright, it has a value, it's stored somewhere in RAM. A pointer is simply the address of where that value is in RAM, okay, the memory address. And remember that memory addresses are nothing more than a hexadecimal number, for example. So 16-bit integer, or 8-bit or 32-bit, whatever memory you have on your system. So the pointer contains the memory address, so it might look something like that, of where a value in memory is. Okay, a value that you want to access at some point, not just any particular memory address. To access that value in memory, referenced by the pointer, so note, okay, the pointer is referencing that value, okay, also known as the value the pointer points to, is another way of saying it. Okay, so I put a little aka in there, is called dereferencing. So to access that value in memory, the one that we want to access, referenced by the pointer, so the pointer is referencing it by its memory address, okay, also known as the value that the pointer points to, is called dereferencing. So these are the major operations that we are going to use with pointers. So let's start with an example. Char x equals 5. And I'm going to call this a value type. It sort of doesn't really apply in the C or C++ language, but we're going to call this a value type. So this is a variable located in memory, okay, in RAM somewhere, that has the value 5. We currently don't know its address. Alright, that's of no interest to us, because normally when we work with variables, we're only interested in the values associated with them. Alright, not where it's actually stored in memory. That's of no use to us normally, until you start working with pointers. To create a pointer, you must always have a pointer in the same data type as the original variable, so char and char, but note we use this little star here, the asterisk. Right, it is the multiply symbol, but when used like this, char, star, whatever this name happens to be, doesn't have to have pointer there, but it's just to make it obvious here, that declares a pointer. Okay, so this declares a pointer to a char. Currently, who knows where it points? Okay, we haven't told it where it's going to point. Okay, just because I've written it underneath this line here doesn't mean that it points to X, even if it's got the same name as it. Okay, it's what's called dangling. It doesn't have anywhere that's particularly pointing to. What we can do though is we can say that value, that pointer, is going to point to X. Reference X by obtaining its address using the ampersand operator. So we can give pointer X a memory address to point to, so it is actually pointing to something, by taking what I've called up here a value type and referencing it, or obtaining the address of that variable. So pointer X now points to X, so if X was located at this address, for example, that was what the compiler chose, pointer X would contain that memory address. And we know later in the program that if we then dereference it, we could obtain that value 5, because that will be stored in that memory location. And I'll show you how we can do this. So if we wanted to, for example, read the value of X back from our pointer, we can dereference that pointer. So dereference the pointer using the asterisk operator, obtaining the value 5 once again. So let's see this again. Char x equals 5. We've got variable x, data type is a chart, contains the value 5, and that's stored somewhere in RAM. We're not sure where. We then declare a pointer, noting that we use the star, and it has to have the same data type as the variable that we want to point to, or the value that we want to point to. Alright, so we're creating a pointer to a char, and we've called it pointer x. Currently, as far as this line's concerned, it doesn't point to anything yet. Okay, it's probably going to contain rubbish. We shouldn't use it. When we actually do want to set its value equal to a real memory address, in this case the address of the variable x, we use this ampersand. So we can now access this variable x via this pointer, because it's now pointing to the memory location of that variable x, and we could pass this around. So this is now a pointer to this variable. And one of the ways we could use that pointer is by then later dereferencing it. So we dereference the pointer using the multiply operator to then extract that value back again. So the value at that memory address will now come back into read of x. So from here we've taken the address of x by using this operator, and then we've taken the value at that address and put it back into read of x. Okay, you might need to read that through a couple of times before you see it for yourself. At the moment this doesn't look so useful, right? We haven't actually done anything that kind of looks useful. We already had the value here. We seem to have created some unnecessary confusion. Okay, we've got a couple of multiply signs that do different things. This is for declaring a pointer. This is for dereferencing it, so take note. It's one of the mistakes a lot of the students make. And of course we've got this reference using the ampersand. So let's see how we can use this, because at the moment we've only complicated matters. Let's say you have a function that, for whatever reasons, you can't return any variables via the left hand side, or perhaps you want to return more than one, so you have to use pointers. Okay, so in this case I've created a function that multiplies the input argument by 2. Now, if I get rid of the pointer and I go indata is equal to indata times 2, and let's say I was to call that function, let's just delete this while loop. Okay, so example of no pointer, I go times 2 of, let's say, y, and I'm going to define y as char y equals 5, or let's say 10 just to be different from the previous one. Okay, if I run this function, y is still equal to 10 here. Why? This is because when we called the times 2 function, what the C compiler does is it takes a copy of the variable y and it passes the copy into this function. So at this point you're operating on a copy of it, and whatever you do to that copy, it gets thrown away at the end, so when you come back here, this variable remains unchanged. Alright? That is the design of the C language. This is where pointers come in. If I do this, and I make indata a pointer, and I pass the memory address of y, so remember y is a variable that's declared, it's located in memory, it's located in RAM. I pass the address of where that variable is located. Okay, so the value at that memory address is 10. The address I pass, where it is in memory, to this function here. And then I apply a couple of dereferencing operators. In this case, this one says take the value at that address of y, because that's what we passed, 10, multiply it by 2, so we get 10 times 2, and then save it into the value at that memory address. So this allows us to use the value at that memory address, the dereferencing operator. This passes a reference to that variable, so that if I now call it here, y is now equal to 20. So example of a pointer. So you can see the advantage of using a pointer here has allowed me to modify the value at this memory address, okay, so this variable, inside this function without having to have anything on the left hand side or allow me to have multiple output arguments if I so wanted to. Alright, so the benefit being that I can now modify variables declared up here within this function and have the value remain changed, the value that's been changed by this function within our main routine. Okay, so it's a good way to be able to modify data without having to worry too much about returning arrays or anything like that, or more complicated data structures. So that's one of the real uses of pointers. Okay, and one of probably the first places that you'll use it to be useful, being able to modify data within a subfunction and have the value be retained, okay, the modified value in your main one. The other place you might see it is with pointer arithmetic, which is actually quite a effective means of working your way through arrays much faster and more efficiently than if you were to use for loops. So let's say you've got a function that is called transmit string, and it's going to transmit a array of characters or a string over the serial port. So this will be the serial port transmit example. So char str for string. Now I'm going to use the open close square brackets. It goes equals hello. Now this is another way to declare a pointer. So just note this, that this open close square brackets, alright, I could go 1, 2, 3, 4, 5, 6 for the null character and put a hard-coded value in here, or I can let the compiler do it by leaving open close brackets. But note that all arrays effectively create a pointer variable. This variable char, this pointer, points to the first letter in this array. So another way of creating a pointer, other than using the star up here, is to use the open close square brackets and define an array. And then as you pass around str, you're not passing around the whole array and all of the data within it, you're only passing around the memory address of the first element within it. So if I was to then use my transmit string function and go str, you'll note I don't need the ampersand, right? Because this is already a string. So that's where a lot of students will also make a mistake when using pointers. This is already a pointer, even though it's an array. The array variable points to the first character within that array, so the memory address of this, of our h, so we can use that directly as a pointer. So I get a pointer in here, I get the memory address of the character h. That's what's going to be come in here by str. And what I'm going to do is I'm going to go while there is a valid character at that memory address, I'm going to wait for tx buffer to be empty, which is, as we do, good practice with serial port. And then we're going to go udr1 is equal to the value at that memory address, the character at that memory address, send it out the serial port, and then post increment the address. Now let's just see how this works. First of all, our while statement. While a valid character exists at that memory address. Alright, so we are dereferencing our array. So we're basically saying give me the character at that memory address. The first one will be h, then e, l, l, o, and then null. All strings terminated in null. Once we get to null, we get while 0, so we exit this while loop. So that one says while we have a valid character, go round and round in here, sending each character. Now this is where it gets a little bit tricky. This one here does the same, dereferences, says what is the character at that memory address, pass it out the serial port and send it, and then increment the memory address. So this is your first example of pointer arithmetic. And in this case we are incrementing the memory address by 1. Right? We are not saying h is equal to h plus 1. Okay, that's not what we're doing. We're not incrementing the value at that memory address. We are incrementing the memory address itself, right? So something like this. If I go plus plus, that goes to 0035, for example. So we're incrementing the memory address. Because our string is stored contiguously, which means that each character is in a consecutive memory location, they're all next to each other in RAM, that means that when I go to the next memory location along, incremented, I will get to, our pointer will now point to E. And if I increment along again, our pointer will now point to L, and so forth. So every time this executes, we dereference, we get the value at the memory address, transmit it, and then we move our pointer along by 1. So we increment our memory address by 1. So we come round again, E is a character, send it, move along by 1, L is a character, O is a character, alright, move along by 1, null is not a character, exit this, and we'll exit out of this function. So we've seen within this example two of the main benefits of using pointers. One is that we can modify variables declared in another function within a subfunction and have the value retained within that main function. Okay, so that can be quite useful, especially for multiple output arguments. We can also see it in terms of pointer arithmetic. So I avoided the need of a for loop here to be able to move through that array. And it was nice because I didn't need to know how long the string was. I can use the fact that they were all terminated in null to be able to transmit, which is a nice feature of it. But as you see when we get to structures in the next video, the third benefit of using pointers is that if I have and we can actually see it here as well, I don't have to pass the entire array to this transmit string function. So I'm not copying 5 bytes, or 6 bytes, including null, to this transmit string function. I'm actually only passing 1 byte containing the address of the beginning of this array to this transmit function. So it saves us copying all of that information over, and therefore it's much more efficient for us to call our functions. Alright, so we save copying needlessly data, like I described as the C compiler works, for every argument. We're only copying over the memory address. And note, even though I've modified the memory address, the pointer address here, once again, this is only a copy. So this pointer here is a copy of this one here. So it doesn't actually modify str up here. It modifies a copy of it. Even though we're still working with the same memory locations, we're working with a copied pointer. To get into that, we get into double pointers, which I think we'll leave for this example.